We've all experienced a strong smell, good or bad, that instantly transported us to another time and place, or alerted us to something dangerous. How can odours do that, and why? In this section, we explore the direct route that olfaction takes into the brain, and how this has such a powerful effect on emotion, memory, reproduction, and even our basic survival. Olfaction is an anatomical and functional exception amongst our senses. Most signals cross over to the opposite hemisphere, e.g. part of the vision from the right eye is channeled over to the left visual area of the brain, but not smell. The olfactory nerves project ipsilaterally, meaning that the pathway from each nostril is directly into the same side of the brain. Incoming sensory messages usually pass through the brainstem and thalamus, which behaves a bit like a switchboard, directing the incoming messages towards the correct area of the cortex. But not smell. Olfactory nerves bypass the thalamus, going straight to the olfactory cortex, amygdala, and hippocampus, regions deeply involved in emotion and memory. The olfactory bulb is essentially an extension of the central nervous system into the nasal cavities. And olfactory neurons display the unique ability to reproduce throughout life. As their dendrites are literally dangling down through the cribriform plate to mix with the mucus and odour molecules present in the nasal passages, the epithelium there, this direct exposure to the environment makes olfaction both highly sensitive and vulnerable to damage and aging. And you can also appreciate from this side view the direct nature of communication from the olfactory bulb to the higher brain centres. There's not very far to travel. On a molecular level, the detection of odorants is beautifully efficient. Odour molecules bind to a specialised protein on the olfactory nerve membrane and initiate a molecular chain reaction. That depolarises the neural membrane and sends an action potential zipping towards the brain. Since each olfactory neuron expresses only one type of receptor, and because there are hundreds of different types of olfactory neurons, their combinations allow us to detect literally trillions of unique smells. The olfactory system's direct wiring to the limbic system, our emotional and memory centres, gives smell its emotional intensity. The hippocampus encodes memories, which is why smells can trigger vividly detailed memories and feelings from our past, called autobiographical memories. But olfaction does more than nostalgia. It's crucial for survival, alerting us to dangers like smoke, gas leaks, or spoiled food. And this function also helps to explain the need for smell to bypass the main switchboard in the brain and go straight to the primal centres like the amygdala that control our responses to danger. Odour can play a pivotal role in our romantic lives too, with studies showing that pheromones, which are odour molecules detected by the vomeronasal organ, are linked to mate attraction based on immune compatibility. And clinically, olfactory loss can be an early sign of neurodegenerative diseases, with changes in smell occurring before memory loss or tremors. In summary, unique structural, functional, and regenerative features make smell a gateway to our emotions and memories, alert us to danger, and even help us pick a partner. The olfactory system offers an exciting and promising delivery pathway for treatment of neurological conditions, and the therapeutic potential for essential oils in this field has only recently begun to be explored.